Good evening, everyone. Today's our today's an extra session for our live interaction session. Uh, in between some topics, we have skipped some portions. So we will be covering all those things in today's session. So uh, we will be discussing majorly of the DH parameters, that is the David-Hartenberg parameters uh, that we couldn't cover uh, properly or extensively during our week 6 interaction session. So that we will be discussing today. Also, along with the other few key questions and key topics from the other weeks also will be discussed today's session. So let's start our today's session, our extra session, with some background or detailed explanation about David-Hartenberg parameters. So this one particularly this David-Hartenberg is the name of two persons who has developed this system of analysis. So we have seen how the endpoint question, suppose for a uh, two-link robot, maybe this L1, L2, this is the end effector position P. So for this two-link robot, or 2R robot, that is robot with two revolute joints. So revolute joints will be, here will be the one joint, here will be the second joint. So how it will change, that we have seen in our previous sessions. So according to the position of this L1 and L2, there will be the position of P will be some uh, relation saying the L1 cos of this angle and L2 cos of next angle, theta 1, theta 2. So this we have seen in our previous sessions. So such a classification may be simple for a 2R case, that is for the cases having only two links, that may be possible. But uh, for systems having higher number of links, that is if you try to solve for a 3R pair, that is 1, 2, 3. So here are L1, L2, L3, three links and three revolute joints. So these revolute joints be 1, 2, 3. So when you solve this uh, question for the end effector P, if you try to solve this particular system itself, you will understand what is the difficulty there. But when the number of links and also the uh, degree of freedom associated with each links, that is L1, L2, L3 changes, the system will becomes entirely difficult to model. So to simplify this, Denavit and Hartenberg brought forward a new methodology of analyzing uh, robot joints with the reduced number of parameters. That is, they only use the 4 parameters. That is, 2 joint parameters and 2 link parameters. That is, simply saying they used only 2 angles and 2 lengths. So that's how they reduced the entire thing. And this is a methodology. It's like a framework or methodology. You can apply this methodology to analyze any of the robotic arms or joints. Even in biomechanics, we can apply these things that we will be discussing later. So what this will be using is like, it will fix a frame. It will fix a coordinate frame to each joints. then it will try to uh, find the relation between each links. Suppose you can see there is a this in here. This is the link one. The red one is the link one, and blue one is the link two. Here it is written as link I and link I minus one. That is, if this is 2, link I is link 2, then this will becomes link 1. So like here, what it's like, here we have 2 links and 3 joins. So we can fix coordinate system at every joins. So uh, this is a join. So one coordinate system will be here. Similarly, another coordinate system is here. Third coordinate system is here. So what we will be doing is like, what is the relation of this coordinate system, that is uh, I minus 1th coordinate system to ith coordinate system. So it will be fixing a relation or finding the relation in terms of only 4 parameters. That's how we are framing this equation. Not sorry, not equation. Framing the relation in with respect to 4 parameters, and this will be uh, written into something like something called a transformation matrix. We will see what's a transformation matrix. Or if you have studied some basic computer graphics or let's say multi-body dynamics or something like that, if you have studied, then you can easily understand what's a transformation matrix. So with this Dynamite-Hartenberg parameters, uh, we can standardize the methods, and we can easily convert, easily standardize the method for analysis of the frames, and convert the relation between the links into matrices. And matrix can be easily but calculated. That is, suppose the relation between these two, that is, here we have joint I minus 1 and joint I. So here it connects between 2 links. So if the relation between this can be written as one transformation matrix Ti, then another will be when we going on to this direction, the next join will be I plus 1. So for I plus 1, there will be some T I plus 1 transformation matrix will be there. That is, it will give the relation between I and I plus 1. It will be giving the relation between T I and I plus 1. So there will be some matrices, and when we need to understand the relation between I minus 1 and I plus 1, that is this one, this one. So when we want to directly calculate or understand the relation between 1 and 3, we can multiply, or we can have a dot product of these uh, matrices to get that relation. So it will be convenient when there is a number of links and joins are greater. So the three important factors are, it's a standardized method, and we can create these matrices, that is transformation matrices, and these transformation matrices can be applied on complex chain. So these three things are the important uh, advantage that Hardenberg brings to us. So here, if you see here, mostly there are, you can see there are some parameters. Let me erase the other things. So you can see here there is a I minus 1 and a1, and here is di, and here is theta I, and there is alpha I. So these are the four parameters where a comma d are the linear length or distances, and theta and alpha are the angles. So these two a and d are the link parameters. Theta and alpha are the joint parameters. So what this is like? This will be literally translating the, even though we have three axes x, y, z, this the right Hartenberg will be reducing mostly into z and x axis. So we'll be fixing z and x axis in directions, and we'll be fixing the angles with the z and x axis only. That's how we can reduce the number of parameters, and this they have found very efficiently. And there also exist a lot of modified DH methods, but let's see what's the first one itself. So we have seen there are four parameters. First one, theta. Theta is the known as the joint angle, and it gives the rotation about z axis, and this is the main thing that is waiting for a revolute joints. That is 2R, 3R. That is, these are kind of representation for revolute pairs. So here for revolute joints, theta is the variable, and it denotes the joint rotation. And uh, first I will discuss both the angles and then lengths. So here alpha is the link twist. This is the rotation about z axis, and this gives the angle between two consecutive z axes. So there is it. So this is the rotation of the theta is the rotation of the link about the z axis, whereas alpha is the angle between two z axes, between the what when we are considering two coordinate systems. So this alpha will denote the angle between two z axis, and that rotation is about not y axis but x axis. So here itself we can see there is only z axis and x axis. Let me show you here. Here you can see the theta. This one is the theta. This is the theta, and theta here if you see, this is this dotted line. This dotted line going in this upward direction is the z1 minus 1 axis. So what this is uh, recording is the angle of rotation of the link I with respect to this z I minus 1 axis. So this is going upward, and this is rotated. Here you can see the frame here is z is upwards and x is thiswards. So if you are setting this x0 is the what initial position or normal position for this joint, then this link is rotated theta I degrees with respect to z I minus 1 axis. So that's what it shows. And next one is alpha. Alpha is the angle between two z axes. So here if you see z I minus 1 axis is in this direction, and z you can draw it here. So z I minus 1 axis is in this direction, and zi axis of the other system is in this direction. This is zi minus 1. This is zi. So these this angle between these two and this rotation is the angle between these two axes, these two z axis, that is the zi minus 1 axis and zi axis, zi and zi minus 1 axis measured in direction of x. So this is the, here if you see xi is in this direction, xi. So in that direction, in that plane, that is, this is being measured in uh, zy plane of this particular axis. So that is the rotation between, or uh, what, orientation between uh, zi minus 1 and zi axis. That's what alpha gives. So these are the two uh, things. And next one is link length. So this a is, here you can say a is link length. So here you can say a I minus 1, that is a I minus 1 is the link length for this I minus 1 the link. Is length of a minus 1. Likewise, a I is the length of a is the length of link k, link I. And next, what is d? D is the translation along the z axis. So how much is the movement of the joints? Okay. This is only this matters for prismatic joints. Prismatic joints are the joints where something can be extended like that when the lengths are varying, that kind of things. So here you can see uh, here uh, from this axis you can see this is coming in here, and from this axis to this axis, that is the height difference between these two coordinate systems, that is OI minus 1 and OI in direction of Z. That's what DI gives. You can see the this origin is situated here and this origin is situated here, and the direction or the distance between this OI OI minus 1 and OI in direction of Z is known as DI. So these are the four DS parameters where theta and alpha are the rotations, D and A are the lengths. So A is the link length, theta is the joint angle, alpha is the link twist, D is the link offset. So how to, now we have seen how to what is the DH parameters. Now how to fix the axis. So here for DH parameters, all the uh, theta, alpha, A and T is only related to either what, Z axis or X axis. So if you see here, uh, theta is related to X axis. Also, link offset is related to Z axis. So theta and D are rotation and translation about Z axis, where A and alpha are uh, distance and rotation about x-axis. So here you can see only z and x are their axis are only considered in DS parameters. And next thing is like how will we fix the x and z axis? So that is the uh, frame assignment rule. So z-axis will be always fixed along the joint axis. So joint is having an axis. So suppose here you can see this joint I rotates in this axis. This is connection of two links and they are connected by a pin joint. So this rotation joint, in what direction will be rotating? It will be rotating about this particular axis. So that particular axis is fixed as z axis. And next, uh, the direction of next joint, that is direction along the link, will be taken as the x axis. You can see here it is true for these two cases. That is, what is the direction or the direction of link? We can simply say it as a direction of link or direction of next z axis. The direction connecting both the z axis will be termed as z axis for that particular joint. So that's why we fix z axis and x axis. See, you can see this is the common normal between two z axis of the two joints. And origin is fixed at the intersection of this x and z axis. So when we are extending these z axis that way, in the previous figure, the axes are coming down to the uh, downward side. Not it is not coinciding inside the links, but it is somewhat uh, outside. So this is the origin will be at the intersection of these x and y, x and z axis, and y axis will be assigned following the right hand rule. And I already told you, like the relation between two coordinate system can be written as a matrix, and that particular matrix is shown here, and it is known as a transformation matrix. It is known as a transformation matrix T, and for ith link we can write it as T of I. So here what this is, I can simply explain you this four things. Sorry, this 3 by 3 matrix is known as the rotation matrix. And this is the translation one. So uh, here, since there is only uh, rotations about uh, z and x axis, only theta and alpha are here. So this is the what split up of this transformation matrix. So this last row is the added to make it a 4 by 4 matrix. So if you see here, this rotation matrix is a 3 by 3 matrix, that is m into n, where m is the number of rows and row by column. So 3 rows and 3 columns. Here you can say it's a 3 rows and 1 column. So it will be 3 by 1. So which will give us a so yes. So this, when combining these two, this will give us what? 3 by 4 matrix. So this is not a square matrix. To make it square, this another line is there, 0 0 0 1. This where this one is a scaling factor. So when not, it does not, it does just not make it uh, 4 by 4 matrix, but that also gives you something called scaling. So when it comes to computer graphics, you know, you can just scroll your mouse to zoom something. So there, these kind of operations, this will be the one varying. There won't be any rotation or something, but that zooming effect, that scaling effect will be given by this factor. So this is the transformation matrix. And for the Navish-Hartenberg parameter, that is, we have to follow this set of operations. First, we have to rotate about when we are fixing. Suppose, uh, like previous section, we have a joint here, and this is L1, this is L2. So we already have one coordinate system here, Z, Y, X. So how to fix the other one? So for even though for this one itself, when the starting point, we have to fix a coordinate system. So first, uh, we will be fixing that system with the before set rules. Then how to find the translation, how this particular coordinate system, that is O, sorry, OI minus 1 fixes with this OI. That's the origin of these two. How you can find this arrangement between these two? Or for that, first rotate about theta. Then that is, it is like, what are the transformations I do to this particular one? What are the transformations I do to this particular let me draw it with the blue or something. So what are the transformations that I do to this particular coordinate system to match it exactly with this one? That will be the relation between these two coordinate systems. So for that, first you have to rotate the z axis. This z axis has to be rotated to align this particular z axis or z axis, and then we will be translating this entire thing, will be moved or translated to this particular point to match OI minus 1 to OI. That if OI minus 1 is the origin of this particular coordinate system and OI is the origin of this coordinate system, then we will be pushing this OI minus 1 to OI. So what is the distance to be moved? That will be D. And then we will be, if it is above or below, then we have to translate along x-axis. First we moved along z-axis. Uh, so that will be the direction of D, and this will be the direction of A. Translation along z z-axis, that is upward direction. So that direction, and translation along x-axis is A. Then we have to rotate about alpha, rotate about x-axis to match both the x-axis, because we have already, first we have aligned the or oriented the z-axis by rotating by theta degree. Then we have translated uh, in what z direction. Then we translated uh, the system along x-axis. Then after these two things, what the position of OI minus 1 and OI becomes same, because this is the translation. From this point, it will be moved to this point. And we did these two operations after fixing the orientation of x-axis. So these three things are already set. Then we will be rotating it along the x-axis to match the axis. So this is the order: rotation about z, translation about z, translation about x, and rotation about x. So this will be the order of operation we will be doing to match or find the relationship between the two uh, transformation matrices. Sorry, two joints or two links. Then that will becomes the that relation becomes the transformation matrix Ti. So we have in our previous sessions we have solved this 2R planar manipulator using our uh, simple linear algebra itself, linear algebra and trigonometry. So here is how we can solve it using our DH parameters. So if you see, I will just quickly complete this thing. So here you can say for link 1, this is the link 1, the angle of rotation with respect to z axis. Keep it in mind that the z axis is coming out of the plane. So this is the xy plane, you can see, and z will be pointing towards us or towards our uh, towards outside the plane. So this will be z0, and something like this will be z. Sorry, this is z. Okay, z1 and z. Okay, z0 and z1 will be in this direction. This will be z2. This will be z3. So that will be all this z axis will be coming out of the plane. So in that way, you can see with the z0 is the fixed link here, the hook or the joint that is fixed to the ground, and this is the rotated axis. So this one is the x0 y0 plane, and this is the x1 y1 thing. X1 y1 is aligned with the link L1. So the rotation is theta 1, and you can see there is no translation. It's like these two what origins are uh, overlapping each other already, because these are kind of complete joints. So here then you can say there is no distance between the origins of these two coordinate systems. So the d becomes 0, and the distance in direction of x, that is distance between two joints, that is O1 and O2, distance between O1 and O2 in the direction of x is x1. Sorry, this x1 in the direction of x1 will be L1. That is the length of the link. That here also we have entered here. And alpha, the rotation between uh, x0 and x1. Sorry, that also not exist. The alpha also not exist. So here it's 0. Likewise, we have given for theta 2. That's the angle between these two axes. These two x-axis with respect to what? The z direction. So that is the theta 2, and L2 is the length in the x2 direction. So only these two parameters is there. So if you remember, I have shown the TI matrix there. You can plug in these values in that particular thing and try to solve it, and you will be ending up with these equations. The same ones we have derived with the help of linear algebra sometimes earlier. So the role of DH or dynamic Hartenberg parameters in biomechanics is that we have most of the industrial robots are made by inspired from human industrial robots. If you have seen these pick and place robots in large industries and all, so these are mostly inspired from our human arm direction. So that is there, and also when this so this is applicable for legs also. That is the lower limbs also. So it will be like if you are considering this hip knee angle chain, the hip will be the joint one, knee will be the joint two, angle will be the joint three. So that's how we can apply the uh, dynamic Hartenberg methods for analyzing the position to the lower limb and upper limb. So let's start with our questions. Okay. So first question: DH convention is used to which of the following? Simple question, comparatively simple question. What is the use of DH convention? Options are option A to compute torques, option B to standardize coordinate frame assignment, option C measure velocities, option D determine mass. So what is the use of DH convention? Is it to compute torques? Option B, is it to standardize the coordinate frame assignment, or is it to uh, measure the velocity of the links, or is it to determine the mass? You can inbox your answers. Yes, the answer is option B, standardize the frame assignment. Option B, standardize the frame assignment. DH is the framework or convention of assigning coordinate systems or coordinate frames to joints, thereby analyzing the orientation of the links. Next question. The standard DS parameters include which among the following? Options are option A, A, B, C, D. Option B, theta, D, K, and alpha. Option C, X, Y, and Z. Option D, M, L, and theta. What are the standard DS parameters? Which among the following consist of the standard DS parameter set? Options are option A, A, B, C, D. Option B, theta, D, A, and alpha. Option C, X, Y, and Z. Option D, ML and theta. Correct answer set is option B, that is theta, t, a, and alpha. Answer is option B, theta, d, a, and alpha. Going to next question. In these parameters, A represent which among the following? So in these parameters, A represent which among the following? Options are, is it option A, is it joint angle? Option B, is it link twist? Option C, is it linked length? Option D, is it joint offset? So which among the following does A represent in these parameters? Option A, joint angle. Option B, link twist. Option C, link length. Option D, joint offset. The correct answer is option C, link length. A is the length of links. So our option C is the correct answer. Option C is the correct answer. Link length. Next question. What does the parameter alpha represents in DH? What does the parameter alpha represents in DH? Options are option A, joint rotation. Option B, link twist angle. Option C, link length. Option D, link displacement. So the next question is, what does the parameter alpha represents in DH parameter? Option A, joint rotation. Option B, link twist. Option C, link length. Option D, joint displacement. Correct answer is option B, link twist angle. Option B, link twist angle. Next question. In revolute joints, the variable parameter is which among the following? Which among the following is the variable parameter in revolute joints? Options are option A, D, option B, A, option C, theta, option D, alpha. So which among the following is the variable parameter in revolute joints? Which among the following is the variable parameter for revolute joints? Options are option A. Option A, D. Option B, the link length A. Option C, the joint angle theta. Option D, the twist angle alpha. Answer is option C, theta. So for revolute joint, the the angles have only revolute rotation with respect to the joints. So here in DS parameters, theta represents the variable parameter for revolute joints rotation. Next question. In prismatic joint, the variable parameter is which among the following? Options are option A, theta, the joint angle, option B, D, option C, A, the length, option D, alpha, the twist angle. So for prismatic joints, what is the variable parameter? Options are theta, D, A, and alpha. So prismatic joints are the joints which can extend, where we can vary the lengths. So if we can uh, vary here in DS parameters, it is taken as D. Next question. The homogeneous transformation matrices are of which order? Options are option A 2 by 2, option B 3 by 3, option C 4 by 4, option D 6 by 6. The homogeneous transformation matrix are of which order? Options are option A 2 by 2, option B 3 by 3, option C 4 by 4, option D 6 by 6. Answer is 4 by 4. Homogeneous transformation matrix is nothing but our TI. Where is we have the 3 by 3 rotation matrix and another 3 by 1 uh, translation matrix and 1 by 4 scaling matrix. The correct answer is option 4 by 4, option C. Next question. The DH transformation matrix combines which among the following? Options are option A rotation only, option B translation only, option C rotational translation, option D velocity terms. We can easily answer the question. We just discussed the above. For the DH transformation matrix, it combines which among the following? Options are option A rotation only, Option B, translation only. Option C, rotation and translation. Option D, velocity terms. The correct answer is, we have seen that transformation matrix consists of both rotation and translation. Option C is the correct answer. Option C, the DH matrix or homogeneous translation matrix combines both rotation and translation. Next question. Then format kinematics using DH parameters involves which among the following? Options are option A, adding matrices. Option B, differentiating matrices. Option C, multiplying successive transformation matrices. Option D, inverting matrices. The forward kinematics using DH parameters involves which among the following? Options are adding matrices. Option B, differentiating the matrices. Option C, multiplying the successive transformation matrices. Option D, inverting matrices. The answer is option C, multiplying the successive transformation matrices. I have already told you that T, if we have three matrices T, I minus 1, Ti, Ti plus 1. So this will be the relation between Ti minus 2. So this will be the relations between four different joints. So then we can find the relation by continuously multiplying. That is what is the relation of Ji minus 2 to Ji plus 1 by continuously multiplying these three matrices. So that is the correct answer, multiplying successive transformation matrices. Next question. The DH convection simplifies the kinematic modeling by which among the following? Options are option A, eliminating the nonlinear equations. Option B, reducing the torque. Option C, providing a systematic frame assignment. Option D, removing singularities. The DH convention simplifies the kinematic modeling by doing which of the following? Options are option A, eliminating nonlinear equations. Option B, reducing the torque. Option C, providing the systematic framework assignment. Option D, removing the singularities. Correct answer is option C, by providing a systematic frame assignment. By providing a systematic frame assignment. Next question. In DH convention, the z-axis is aligned with what? Options are option A, link length, option B, joint axis, option C, normal vector, option D, end effector position or end effector direction. In DH convention, the z-axis is aligned with what? Options are option A, link length, option B, joint axis, option C, normal vector, option D, end effector direction. Answer is option B, joint axis. Correct answer is option B, joint axis. Joint axis. Next question. The x-axis in DH convention is defined along which direction? Options are option A, is defined along joint rotation axis. Option B, defined along gravity direction. Option C, defined as the common normal between z axis. Option D, link twist. In what direction is the x-axis in DH convention defined along? Options are option A, joint rotation axis, gravity direction. Option C, common normal between the z axis. Option D, along the link twist. Correct answer is option C. Option C, common normal between z axis. Common normal between z axis is the direction of x axis. Next question. The parameter D represents which among the following? What does the parameter D represents? Options are option A, distance along the z axis. Option B, distance along the sorry, option A, distance along the x axis. Option B, distance along the z axis. Option C, angle about the z axis. Option D, angle about the x axis. What does the parameter D represents in DS parameters? Options are option A, distance along x axis. Option B, distance along z axis. Option C, angle about z axis. Option D, angle about x axis. The correct answer is the distance along z axis. Option B, the distance along z axis. Next question. What does the parameter theta represents? What does the parameter theta represents? Options are option A, rotation about z axis. Option B, translation along z axis. Option C, translation along x axis. Option D, rotation about x axis. What does the parameter theta represents? Yes, the theta is the joint angle. Theta is the joint angle. It is the rotation about the z axis. Next question. The transformation between two consecutive links is performed in how many steps in standard DH? The transformation between two consecutive links is performed in how many steps in the standard dynamic Hartenberg process? Options are through two transformations. Option B, three transformations. Option C, four transformations. Option D, six transformations. The transformation between two consecutive links is performed in how many steps in standard DH? Options are option A, two transformation, option B, three transformations, option C, four transformations, option D, six transformations. Answer is option C, four transformations. We will be doing two transformations with respect to z axis and two uh, in z axis and two in x axis. So 2 plus 2 is equal to 4. The next question. What is the correct order of transformation in a standard DH convention? We have discussed the order of transformation just before. So what is the correct order of the transformation in DH convention? Options are option A, rotate along x-axis, translate along z-axis, then rotate along z-axis, and translate along x-axis. Option B, rotate along z, translate along z, translate along x, and rotate along x. Option C, translate along x, rotate along x, then translate along z, and rotate along z. Option D, rotate about z, rotate about x, translate along x, translate along z, which is the correct order of transformations in DH convention. The correct order of transformations in the standard DH conventions. Is it rotate about x, translate along z, rotate about z, translate along x? Or is it rotating about z followed by translating along z, uh, then translating along x and rotating about x? Or is it option C, translating along x, rotating about x axis, translating along z axis, rotating about z axis? Or option D, rotating about z axis, rotating about x axis, then translating along x, followed by translating along z? Correct answer is option B, that is rotating along, sorry, rotating about z axis, then translating along z axis, then translating along x axis and rotating about x axis. Answer is option B. Next question. When two consecutive z axes intersect, what is the link length A become? When two consecutive z axes intersect, the link length A becomes what? Options are option A, maximum, option B, 0, option C, infinite, option D, negative. What is the value of link length A when two consecutive z axes intersect? The answer is option B, 0. When both z axes intersect, the link length, because the translation along x axis is the link length A. So then there won't be any translation between these two z axis difference between. So the answer is 0. Option B, 0. Next question. When two consecutive z-axes are parallel, the link twist alpha is what? When two z-axes are parallel. Before the question, it was intersecting. Here it is parallel. So, when two z-axes are parallel, the link twist alpha is what? Options are option A, 0, option B, 90°, option C, 180°, option D, undefined. When two consecutive z-axes are parallel, what will be the link twist alpha? Here also the answer is 0 when two z-axes are parallel, two consecutive z-axes are parallel, the length twist alpha becomes 0. Alpha is equal to 0 when z-axes are parallel. Next question. The homogeneous transformation matrix includes which among the following? We have already seen this. It has both rotation and translation components. It's like the question is repeated. So here only the changes are in options. So only rotation submatrix, only translation vector, D only scaling times. So our correct answer is rotation and translation components. Option C is the correct answer. Next question. What is the last row of homogeneous transformation matrix? The last row of homogeneous transformation matrix is always which among the following? Options are option A 1 1 1 1, option B 0 0 0 and 1, option C 0 1 0 1, option D 1 0 0 0. Which among the following is the last row of homogeneous transformation matrix? Correct answer is option B. That is, the last row of the homogeneous transformation matrix will always be triple zeros and one, where it's a scaling component. Next question. In DH notation, the alpha is measured about which axis? Options are option A, z-axis, option B, y-axis, option C, x-axis, option D, any arbitrary axis. The parameter alpha in DH notation is measured about which axis? Options are option A, z-axis, option B, y-axis, option option C, x-axis, option D, any arbitrary axis. Answer is option C, that is x-axis. If you remember, it is like rotation about z, translation about z, translation about x, then translation about x, rotation about x. So it's like theta d a alpha. That's the order. Next question. For a revolute joint. So here the question is particularly for revolute joint. For a revolute joint, which parameter remains constant? Options are option A, theta, option B, D, option C, both theta and D will vary, option D, none of the parameters remain constant. Here the question is on revolute joint. For a revolute joint, which parameters remains constant? Is it theta, is it D, or both theta and D will vary, or none of the parameters remain constant? correct answer is option B, that is D. For revolute joint, theta only varies. Only theta varies and D remains constant. So, correct answer is option B. Next question. For a prismatic joint, which parameter varies? For a prismatic joint, which parameter varies? Options are option A, theta, option B, alpha, option C, D, option D, A. This also we have discussed before. So, correct answer is option C, that is D only varies for prismatic joints. The next question. The primary advantage of DH convention. What is the primary advantage of the Dynavit-Hartenberg convention? Options are option A, it eliminates the need for matrices. Option B, it simplifies the dynamic equations. Option C, provides a systematic kinematic representation. Option D, reduces the number of joints. Correct answer is option C, provides a systematic kinematic representation. This is wrong because it mostly works on matrices, and this is uh, there is no force terms here, so there is no dynamic equations here, so that's also wrong, and it can't do anything to reduce the number of joints. It is simply finding the relation between the joints. So correct answer is option C. Next question. The errors in assigning DH frames will typically lead to which among the following? Options are option A, incorrect torque values only. Option B, incorrect kinematic transformations. Option C, only orientation errors. Option D, no effect will result. Errors in assigning DH frames will typically lead to which among the following? Options are incorrect torque values. Option B, incorrect kinematic transformations. Option C, only orientation errors. Option D, no effect on results. Correct answer is option B, incorrect kinematic transformations. So in DH there is no force or torque values, so option A is incorrect. Option B, incorrect kinematic transformation, that is DH frames are used to find the kinematic transformation between two joints or two links. So option B is the correct answers. Correct answer. Next question. Now moving on to our other topics. This question is on enslavement. Question is, if passive fingers generate force without movement, it indicates which among the following? If passive force generate force without movement, then it indicates which among the following? Option A, stationarity. Option B, fatigue. Option C, enslavement. Option D, reflex. Correct answer is option C, enslavement. Option C, enslavement. Forced generation without intention is the enslaving effect. Next question. Which system is primarily responsible for coordinating finger force coordination? Options are option A, the skeletal system, option B, the central nervous system, option C, circulatory system, option D, integumentary system. Which of the which system is primarily responsible for the coordination of finger force distribution? Options are option A, skeletal system, option B, central nervous system, option C, circulatory system, option D, integumentary system. Correct answer is option B, central nervous system for the CNS. CNS for central nervous system is the correct answer. CNS controls the coordinated finger force activation or finger activation. So is the central nervous system or CNS is the correct answer. Next question. The increasing enslaving effect reduces the which among the following? Options are option A, strength, option B, blood flow, option C, muscle size, option D, dexterity. Increasing the enslaving effect reduces which of the following? Options are option A, strength, option B, blood flow, option C, muscle size, option D, dexterity. Answer is option B, dexterity. Once the enslavement increases, as the enslaving effect increases, it will reduce the precise precise movement or control of our fingers. So increasing enslaving effect reduces the dexterity. More coupling reduces the fine motor control. Next question. Which property is best assessed using individuation index? Which property is best assessed using individuation index? Options are option A, strength, option B, coordination, option C, independence, option D, speed. So which property is best assessed using individuation index? Is it strength, coordination, independence, or speed? So our correct answer is option C, independence. Option C, independence. So individuation, it's pretty intuitive. From individuation, independence. The property assessed using individuation index is independence of the fingers. Individuation index is written as II, measures the finger independence. Next question. A symmetric enslavement matrix implies what? A symmetric enslavement matrix implies which among the following? Options are option A, equal bidirectional coupling, option no coupling, option C, random noise, option D, error. Correct answer is option A, that is. Next question. Which factor least affects the enslaving effect? Which factor least affects the enslaving effect? Options are option A, neural activation, option B, tendon linkage, option C, wrist posture, option D, muscle coordination. Which of the following factors affects the enslaving effect least? Options are option A, neural activation, option B, tendon linkage, option C, wrist posture, option D, muscle coordination. Correct answer is option C, wrist posture. So wrist portion affects the enslaving effects very minimally or not. The wrist portion shows minimal effect on enslaving effect. Next question. What does high stationarity index indicate? What does the high stationarity index indicate? Options are option A, passive finger movement, option B, stable passive fingers, option C, high enslaving effect, option D, weak muscles. Option A, passive finger movement, option B, stable passive fingers, option C, high enslaving effect, option D, weak muscles. Correct answer is option B, stable passive fingers. Stable passive fingers. Stationarity is the ability to remain stationary when the active fingers are in motion. Correct answer is option B, stable passive fingers. Passive fingers may remain stationary. Next question. Which experiment best isolates mechanical coupling? Which experiments best isolates mechanical coupling? Options are option A, varying force levels, option B, changing wrist posture, option C, measure EMG, option D, increase the repetitions. Correct answer is option B, that is change in the wrist posture. Change in the wrist posture is the correct answer. Next question. The neural overlap in motor control leads to which among the following? The neural overlap in the motor control leads to which among the following? Options are option A, increased independence, option B, finger coupling, option C, reduced force, option D, faster movement. What does the neural overlap in motor control leads to? Options are option A, increased independence, option B, finger coupling, option C, reduced force, option D, faster movements. Correct answer is option B. Correct answer is finger coupling. Option B. Shared neural pathways causes finger coupling or Nernst-Levin effect. Next question. The bone cross-sectional geometry helps resist bending mainly by increasing which of the following? The bone cross-sectional geometry helps resist bending mainly by increasing which among the following? Options are option A, elastic modulus, option B, yield strength, option C, density, option D, moment of inertia. The bone cross-sectional geometry helps resist bending mainly by increasing which among the following? Options are option A, elastic modulus, option B, yield strength, option C, density, option D, moment of inertia. Correct answer is option D, moment of inertia. Option D, moment of inertia. The bone cross section is in a way that it will increase the moment of inertia, which helps resisting the bending. The larger the moment of inertia, higher the bending resistance. Next question. When stresses are applied and then released, the stress strain cycles are not reversible. This is known as which among the following? When the stresses are applied and released, these stress strain cycles are not reversible. This is known as which among the following? Options are option A, creep, option B, stress relaxation, option C, hysteresis, option D, strain. What is the irreversible effect of strain cycle? Stress strain cycle is known as. Is it option A, creep, option B, stress relaxation, option C, hysteresis, option D, strain? Correct answer is option C, hysteresis. Option C, hysteresis is the correct answer. The reversible loading unloading path indicates hysteresis energy loss. Next question. The decrease in stress over time under constant deformation is called which among the following? The decrease in stress over time under constant deformation is called option A, creep, option B, stress relaxation, option C, hysteresis, option D, strain. The decrease in stress over time under constant deformation is known as which among the following? Correct answer is option B, stress relaxation. Option B, stress relaxation. Stress relaxation is the decrease in stress over time under constant deformation. Next question. This question is from viscoelastic models. A Maxwell body is modeled as what? From this is from viscoelastic models. Question is a Maxwell body is modeled as which among the following? Options are option A dashboard and spring in series. Option B, a spring and dashboard in parallel. Option C, a spring and dashboard in series connected in parallel with another spring. Option D, a spring and dashboard in series connected parallel with another dashboard. So which among the following is defines a Maxwell's bodies best? Is it a dashboard and spring in series, or is it a spring and dashboard in parallel, a spring and dashboard in series connected in parallel with another spring, or option D, a spring and dashboard in series connected in parallel with another dashboard? Correct answer is option A dashboard and spring in series. A Maxwell body is defined by or modeled as a dashboard and spring in series. Maxwell model consists of series, elastic, and viscous elements. As to series. Next question. A sudden application of constant force is mathematically represented by which among the following? Options are a Dirac delta function, option B ramp function, option C Heaviside step function, option D sine function. A sudden application of constant force is mathematically represented by which among the following? Options are option A Dirac delta function, option B ramp function, option C Heaviside step function, option D sine function. Correct answer is option C Heaviside step function. So if this is the graph, if there is a sudden jump in force and then it is constant, so it will like a step function, and this is a Heaviside step function or Heaviside step function. The step function represents the instant load maintained constant afterwards. The step function represents an instant load maintained constant afterwards. Next question. What is the Kelvin model of viscoelasticity? Options are option A spring and dashboard in series, option B spring and dashboard in parallel, option C series of springs and dashboard, option D spring and dashboard in series connected in parallel with another spring. So here it's asking what is the Kelvin model of viscoelasticity. Is it option A, spring and dashboard in series? Option B, spring and dashboard in parallel? Option C, series of springs and dashboards? Option D, spring and dashboard in series connected with parallel with another spring. Correct answer is option B, spring and dashboard in parallel. Kelvin model presents the spring and dashboard in parallel. Next question. The standard linear model